Well, so good morning, everybody. I'm Mr. Dellago, and as the director of the Thirring Institute, I would like to welcome you to this celebration of the life achievements of Walter Thirring, who would have turned 90 exactly today. So I would, in particular, specifically like to welcome Professor Carpenter, the Dean of the Faculty of Mathematics, and Professor Yngvason, Dean of the Faculty of Physics. A particularly warm welcome to the members of the family of Walter Thirring. It's really great to have you here. Walter Thirring has done many wonderful things in his life, and we will hear about them in the presentations this morning and in the afternoon. One of the important legacies, I think, of Walter Thirring is the Erwin Schrödinger Institute. And I think this is a legacy that goes far beyond his immediate field of his own science. As most of you know, Walter Thirring played a very important role in the foundation of the Erwin Schrödinger Institute, taking advantage of a window of opportunity that arose due to the dramatic events following the collapse of the Soviet Union. He, together with others, and a few of them are here, I think both highly now, both Peter Vito, I'm sure I'm forgetting a few. They started an initiative, in part also to help scientists in Eastern Europe who lost their jobs or, to have a place where they could come and work at least temporarily. So this initiative was successful. I'm sure not to a small part due to the international stature that Walter Thirring had. And in 1993, the Erwin Schrödinger Institute opened its doors. Now, almost 25 years later, the Schrödinger Institute still exists. There were some difficult times, and it's still running strong. Sometimes some things have changed since the good old days. Some things have stayed the same. The things that have changed are that the Schrödinger Institute changed its address. Originally it was in the Thirring, just down the Stuhlhofstiege. Also it became a part of the University of Vienna. The Schrödinger Institute also changed its scope. Originally it was focused on mathematical physics. Today it encompasses all of physics and mathematics, and this change is also reflected in a change of name. The Erwin Schrödinger Institute is now the Erwin Schrödinger Institute for Mathematics and Physics. Some other things, fortunately, have stayed the same, and we are working hard actually to keep them that way. Right from the beginning, the Schrödinger Institute followed some principles. These principles are internationality, high scientific standards, and a very lean administration. I think this is what Walter Thirring had in mind for the Schrödinger Institute, and I'd like to think that Walter Thirring approves of how the Schrödinger Institute runs today. Maybe he would be proud to see how the Schrödinger Institute is doing at the moment. So I think it is very fitting that this symposium here honoring Walter Thirring takes place here at the EASI, and I'd like to thank the organizers for making that possible. I'd also like to thank of course, the speakers for coming and sharing their recollections with us. And then, of course, we would like to thank all of you for coming and taking part in this event. Thank you.
Liebe Mitglieder der Familie Thirring, Spectabiles, Gonza und Krattenthaler, colleagues and friends, ladies and gentlemen. Walter Thirring was one of Austria's most famous scientists during his long and distinguished career. He made seminal contributions to many areas of theoretical physics, and can justly be called one of the founders of modern mathematical physics. And as Christoph, our director, mentioned, it is very fitting that this memorial symposium on his 90th birthday is held here at the Erwin Schrödinger Institute, which would not exist without his strong commitment in its founding period in the early 90s. My introduction to the scientific program will consist of a biographical sketch and comments on Walter's scientific contributions, together with some personal remarks. Walter was born in Vienna on the 29th of April 1927 as son of a physicist and professor of the University of Vienna, Hans Thirring, who is in particular known for the Lense-Thirring effect in general relativity, which concerns the effect of rotating masses on the gravitational field. Hans Thirring was an active pacifist and was dismissed from his academic post a few days after Austria's Anschluss to Nazi Germany in 1938. He was, however, reinstated after the war and became dean of the philosophical faculty of the university. Walter's grandfather was also a physicist, and an elder brother had been designated to carry on with this family tradition. Walter, on the other hand, initially aimed at a career as a musician. The death of the brother at the East Front towards the end of the Second World War changed Walter's plans, and right after the war he took up the study of physics at the University of Innsbruck. He did so even without having the formal qualification of a high school diploma, matura, and obtained his PhD in 1949 at the age of 22. I would like to remark that in 2009 he was awarded a matura honoris causa from the Neulandschule in Wien, Favoriten, at the age of 82. He already had, of course, many doctorates of honoris causa, but this is something special. Now, the 10 years following his PhD were Walter's Wanderjahre, which he spent at various research institutions in Europe and the USA. The most important stations were the Institute for Advanced Studies in Dublin, the University of Glasgow, the Max Planck Institute in Göttingen, the ETH in Zurich, the University of Bern, the Institute for Advanced Studies in Princeton, the MIT in Cambridge, Massachusetts, and the University of Washington in Seattle. During this time, he had contacts with Erwin Schrödinger in Dublin, Werner Heisenberg in Göttingen, Wolfgang Pauli in Zurich, and Albert Einstein in Princeton. So he really knew all the great and famous names of 20th century physics. In 1952, Walter married Helga Georgiades, who accompanied him for 58 years until her death in 2010. They are survived by their sons, Klaus and Peter, and 4 grandchildren. In 1959, Walter followed his father as professor of theoretical physics at the University of Vienna until his retirement in 1995. Apart from an interlude, 1968 to 71, when he was head of the theory division of CERN in Geneva. He played a crucial role in the founding of the International Association of Mathematical Physics in the 70s, and was the first president of that organization, 1976 to 78. He was also the founding president and first director of the Erwin Schrödinger International Institute for Mathematical Physics here in Vienna. And from 1998 to his death, he was honorary president of the association, which ran the institute until 2011, when the AC became a research center of the University of Vienna. I would like to remark or recall what Christoph Dellago said, that the present name of the institute is now Institute of Mathematics and Physics, reflecting more accurately the scope of its activities. In fact, from the very beginning, it was not limited to mathematical physics and not to physics, but really both. So this is, I think, perfectly okay. While the association, which still exists and is one of the organizers of this symposium, together with the Research Center and the Faculty of Physics, it still retains the original name. Well, partly for nostalgia, as I say, as partly for vereinspolizeiliche reasons, I guess. Well, besides his role as in the founding of the AC, Walter was also an initiator of the High Energy Physics Institute of the Austrian Academy of Sciences, which takes part in experiments performed at CERN. The wide range of Walter's research interests and the depth of and quality of his scientific work is amply documented in the selected papers of Walter E. Thirring with commentaries, which the American Mathematical Society brought out in 1998. The foreword is written by Elliot Lee, but his commentaries are by Walter himself. So I can really warmly recommend this volume, which is quite a remarkable collection of excellent work and with commentaries from the author, which is also very, very valuable. Walter was not a mathematical physicist from the outset, but started his research career as a brilliant theoretician with focus on high-energy physics and became well known as such already in the 1950s. In this period fall his papers on the divergence of perturbational series in quantum field theory, the discovery of an exactly soluble model in relativistic quantum field theory, known as the Thirring model, and his monography on quantum electrodynamics. The remarkable papers on the number of fundamental fields and three-field theory of strong interactions contain ideas pointing to the eightfold way and the theory of quarks that was developed later by Gell-Mann and Neyman. I expect we will hear more about these things and his contributions to high-energy physics in the talk by Otto Nachtmann here. In the 1960s, Thirring's research interests broadened and he extended his repertoire. First in the areas of general relativity and statistical physics, and subsequently in condensed matter physics and the physics of atoms and molecules. At the same time, his papers became more mathematical, and he developed his distinctive style using modern mathematics to solve hard problems in physics. He was one of the first to use concepts and notations of modern differential geometry in general relativity, and in his other areas of interest, he used sophisticated techniques from functional analysis and the theory of operator algebras. It is truly remarkable how quickly he was able to absorb and apply these methods that were certainly not part of the mathematical curriculum for physics students during his studies in the late 40s. But despite his mathematical skills, his motivations came always from physics, and his work was guided by deep physical insight and intuition for the tools that would be appropriate for the physical problem at hand. Characteristic for Walter's scientific work is the wealth of topics he was interested in and worked on. In this respect, he is for me the model case of a mathematical physicist. One sometimes distinguishes between method-oriented and problem-oriented approaches in science, and sometimes mathematical physics is regarded as being a discipline solely defined by its methods. I think this is a misunderstanding, because in any field there are practitioners that have acquired some skill in a specific method and spend most of their professional life in searching for and working on problems in which this method can be applied. This is very often perfectly justified, in particular in disciplines that rely heavily on expensive experimental equipment. So then this is perfectly justified, at least for a certain amount of time. But when it comes to the bottom of things in physics, the true aim of the game is to understand how nature ticks at its fundamental level. And for this task, the methods have to be chosen to fit the questions attacked. I'd also like to add here, because I was talking about lots about mathematics, that Walter certainly did not shun from using numerical methods when that brought additional insights in this, and in particular he he wrote many papers with Harald Posch on numerical evaluations and studies of his models. In the 1970s, Thirring became interested in the quantum theory of many-body systems and the electric and or gravitational Coulomb forces. This led to his joint work with Elliot Leib on stability of matter. That is one of the crown jewels of 20th century physics, mathematical physics. This work has been very influential and triggered manifold developments both in mathematics and in physics. In particular, the Leib-Thirring inequality, which was the basis for the new approach to this stability of matter problem, has subsequently been generalized and extended in many ways. And if you Google Leib-Thirring inequality or inequalities, you will get 11,000 entries. Thirring's course in mathematical physics is a lasting legacy to his role as a researcher and academic teacher. This work comprises 4 volumes covering classical mechanics, classical field theory, the quantum physics of atoms and molecules, and the quantum theory of large systems. It's a true classic with a breathtaking wealth of information and insights that will continue to educate and inspire many future generations of mathematical physicists as it did in the past. One reason for this is Walter's awesome skill in distilling a complicated mathematical argument into a few lines. Sometimes the result has the character of a spiritus concentratus that must be diluted again to bring it back to drinking strength. And this is in fact what I have done on several occasions when lecturing to students. Now, such elaborations have a pedagogical merit, but I sometimes wondered if I was not depriving the students of the experience of being exposed directly to the hard stuff. Also, Walter's method takes less time, and I have never in my courses managed to cover a comparable amount of material as Walter apparently did in his courses. There is another aspect of Walter's style, working style, that I have often wished I could imitate: his extreme discipline and organization. When he had administrative duties at the university before his retirement, he managed them very efficiently and kept them in time slots well separated from other things. In this way, he had plenty of time for the things he liked most, doing physics, playing the organ, and composing music. Walter Thirring received numerous awards and honors for his scientific work. In addition to the Henri Poincaré Prize, the highest award given by the International Association of Mathematical Physics, he was recipient of the Max Planck Medal of the German Physical Society and the Austrian Großes Ehrenkreuz für Wissenschaft und Kunst. He was member of the Austrian Academy of Sciences, the National Academy of Sciences in Washington, the Pontificia Academia Scientiarum in Rome, the Hungarian Academy of Sciences, and the Academy Leopoldina in Halle, and held honorary doctorates from several universities. Physics was not the only intellectual passion of Walter Thirring. Although fate had prevented him from taking up a career as a musician, he composed many works, in particular for the organ, but also for other instruments. I remember listening to string quartets composed by him on one of his birthdays. String quartet is really a very difficult format for composer. Whenever possible, he would play the organ for several hours a day. And he was also, besides music, he was genuinely interested in a dialogue between science and religion. And this is witnessed in his book, Cosmic Impressions, Traces of God in the Laws of Nature. A further book of his, which was aimed at a general readership, is The Joy of Discovery, Great Encounters Along the Way. And this book contains very interesting autobiographical material, and I can really warmly recommend it to you, those of you who have not read it. Walter Thirring is remembered by his students, friends and colleagues, not only as a brilliant scientist and teacher, but also for his impressive personality and human qualities. Thank you very much.